Welcome back to the flipped class. Today I'm going to take you through 3 individual lessons. You can watch the entire video now. You can break it into chunks as we go through it. These 3 tie together very well, and also I don't want to spend a lot of time on any of the 3 lessons because I think they're things that you can pick up maybe even a little bit greater in class, working more hands-on. Okay, but I do want to show you a few things and just to give you something that you can reference back to if you'd like to look back while working on some of your homework or review the concepts. So we're going to talk about angle measurements and polygons. Then we're going to talk about perimeter, and then circles and circumference. Okay? But first, quick brain teaser, real quick. Okay, a man was rushing to get to his friend's house and ran through a stop sign. 2 police officers saw him and did nothing. Why did they not stop him for running the stop sign? Okay, try to figure that one out. Bring me an answer next time I see you. All right. Some of this should be should be review for you, but just a couple of quick examples of some geometric concepts I want to look at. First of all, this is a 90-degree angle. It means it is a right angle. Okay, this, oops, well, that's not very good, but obviously is less than 90 degrees, so it is an acute angle. And I always think if it's smaller than 90 degrees, think about like a small puppy or a small kitty. Oh, it's such a cute little angle. Oh, it's a cute little angle, right? Get it? Acute? Okay, haha, right? All right, this angle, if you have 90 degrees here, this angle is obviously larger than 90, so that would be an obtuse angle. So we have right angle is 90 degrees, acute angle is 89 degrees and less. Obtuse would be 91 and higher. Okay, in your book they show you a couple different ways to measure angles, and they show you some polygons. So you would have, there'd be more to the shape, for example. This is one way they show you how to do it. I don't have a problem with this way, okay, but I'm gonna show you a couple different ways to do it, okay? They have you center, and obviously this is just a drawing. It's not the best drawing in the world, but it'll get us there for now anyway. They have you center together 2 angles, or the vertices of 2 angles, or of an angle, excuse me. And they show you that, okay, well, this crosses at 120, and this other part crosses at 40. 120 minus 40 is 80. 80 degrees is obviously less than 90, so that is an acute angle. Okay, you can also look at it if you wanted to. Crosses at 60, crosses at 140, 140 minus 60, also 80, 80 degrees. Okay, that's an acute angle right there. All right, I like to do it this way. Let's say this is the same shape, close enough, okay. I would move the page or move the protractor to where, yes, your vertices is still in the center, but you have one that lines up with this line on your protractor. And then the other one should go through at 80 degrees. How do I know it's 80 and not 100? Well, it's obviously less than 90, so it can't be 100. 80 is less than 90, 100 is greater. So that's 80 degrees, and I know that is an acute angle. Okay, now we're jumping into perimeter, all right? The perimeter of a figure is the distance around it. I always kind of like to think about perimeter as like a fence, a fence that goes around your entire backyard, let's say. That would be the perimeter of your fence. It doesn't include the yard, it goes around the yard. So here we have a polygon, and I'm drawing with this blue. The perimeter would be all of the sides, all the way around, okay? So if I wanted to find the perimeter of this figure, if I wanted to, let's say I wanted to estimate it. Okay, I see 10 and 10 is 20, plus 14 is 24, plus 7.5 plus 7.5. Well, let's round those to 8, so I have 24 plus 8 is 32, plus 8 is 40. So my estimate would be the perimeter is about 40, and we'll say centimeters. Okay, so that's my estimate. If I wanted to find the actual perimeter, well, it's very simple. On a polygon like this, I just need to add. So I have 14 plus 10 plus 10 plus 7.5, and you notice that I'm lining up the decimals, plus, whoops, my mistake, plus 7.5. Decimals are lined up. You can add in zeros if you'd like. 0.5 plus 0.5 gives us 1. Drop the 0, carry the 1, drop my decimal down. 7 plus 7 is 14, plus 4 is 18, plus 1 is 19. Drop the 9, carry the 1. 1 plus 1 plus 1 plus 1 is 4. The actual perimeter is 49 centimeters. Okay, that's the actual perimeter of this particular polygon. Adding up the outside. Okay, now there are going to be situations where you have to use what knowledge you have of the polygon to fill in some blanks. Let's look at that. Okay, I've given you another polygon. Now it's hand-drawn, obviously it's not the best, okay? But you notice something different. I've got a variable in here. If I want to find the perimeter, I'm going to need to find out what B equals. Now I want to point a couple of things out. This side is 8, and we'll say centimeters again, 8 centimeters long. This is 10. This is 5. This side is 4. This is 3. And then this side is our unknown. We don't know what B is. But I want to point something out to you. Maybe you've noticed it already. This side is 8. This side plus this side, isn't that the same distance? You have 5 and 3 also equal to 8. So wouldn't it make sense, and I'll use green here, that if I'm going from here to find B, that I would go from here to here, and it would be the same distance? Well, I know that this much of that is 10, and I know that the other part of that would be 4, so I see that my 10 plus my 4 would take me all the way across, and my B would give me 14. Okay, so now that I have that, I've found the missing side. Now it's very easy to calculate the perimeter. Okay, I have 10 plus 4 is 14, plus 5 is 19, plus 3 is 22, plus 8 is 30, plus B, or 14, my perimeter, 44 centimeters. One other quick side, you may have seen this before, you may not have. If you have a rectangle, okay, there is a formula for that. Perimeter equals 2L plus 2W. Okay, L would be the length, W would be the width. Okay, so let's say that this length was 5 and the width was 3. Okay, well, I can substitute 5 and 3. 2 times 5 is 10, plus 2 times 6, or excuse me, 2 times 3, gave it away. 2 times 3 is 6. 10 plus 6 is 16, so the perimeter equals 16. Okay, let's check that. I'm going to erase this, get this out of the way here. Okay, it is a rectangle, so I know that this side is the same length as this side, so I'll put my 5 here, and the width over here is the same as the width over here, so I've got a 3. Add those up. 5 plus 5 is 10, plus 3 is 13, plus 3 is 16. My answer is the same. Perimeter is 16. Okay, and finally, let's talk about circles and circumference. Okay, any circle is named by its center. So if we're going to say that this is the center of our circle, and we're going to call that, we'll call it C. Okay, this would be circle C. Okay, if I have a line that goes from the dead center, which is C in this case, to the outside, we'll call this B, that's called radius. Okay, I can have more than one radius. I can go over here and that can be A. Go over here and that can be D. All right, so anywhere from the outside to the center is going to be a radius, or radii. If you look at DA, from D to A, all the way across, going through the center, that's called diameter. And that's going all the way through. Okay, I'm going to give you a term that you've probably heard before, but the ratio of circumference to diameter, or CD, and I know we're getting pretty in-depth, but this will all make sense once we start to use it, okay, is the same for any circle. That's represented by a Greek letter, okay, which is read as pi. So you've heard of pi before. Pi goes on and on forever without repeating, okay? So to make it easier, we're looking at 3.14. To make multiplying by pi easier, if we want to round, and sometimes we will, sometimes we won't, we can say that it's 3. To find the circumference, or the area all the way around the circle, there's two ways to do it. You can look at circumference equals pi times diameter, and if you remember, diameter goes all the way across, or you can look at it as circumference, because sometimes we don't have the diameter. Sometimes we just have the radius, which only goes halfway across. Circumference equals 2 pi times the radius, which makes sense because if the radius only goes halfway across, multiply it by 2, you're going to get the full distance. Okay, let's look at a couple of examples here. So I have a circle, and I have the diameter, because it goes all the way through, the diameter is 8 feet. If I want to find the circumference, I know that circumference equals diameter times pi. So circumference would equal 8 times 3.14. Okay, let's do a little math. 3.14 times 8. 8 times 4 is 32. Drop the 2, carry the 3. 8 times 1 is 8. Plus 3 is 11. Drop the 1. Carry the 1. 8 times 3 is 24. Plus 1. 25. My decimal moves twice, so I move it twice. So in this case, circumference would be 25.12. I want to make sure I label it. Feet. 25.12 feet. Let's try another one. Okay, I have a different circle for us. In this case, they've only given us the radius, which is 3 centimeters. It only goes halfway across. It doesn't go all the way through the circle, so it's a radius. I know that circumference equals 2 pi r. Okay, so let's fill in the blanks. 2 times 3.14 times r, which is our radius, which is 3. Okay, so it's all multiplication, so we'll just go all the way across. 3.14 times 2. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. I've got 2 decimal moves, so I move it twice. So I have 6.28. I've done that part of the problem. Now I need to multiply by 3. 3 times 8 is 24. Drop the 4, carry the 2. 3 times 2 is 6, plus 2 is 8. 3 times 6 is 18. My decimal moves twice. So in this case, our circumference is 18.84 centimeters. Okay, I know that's a lot of information for you. Again, I feel like these three all go together and they're all very quick, so I think that you can come back and look at certain parts of the video as you want to, as you need to, and we'll check out more of these concepts and talk more about them even more in depth in class. Can't wait. I'll see you then.